Alright, in this video I'm going to look at multiplying complex numbers. So if you look at example 1 with me, I have 4I times negative 6 plus I. Now when multiplying complex numbers, you can almost think of this I, this imaginary number, like it's an x or a variable, because you're going to ultimately follow the same steps as you would if it were. So whenever I have a numerical value or term out in front of parentheses and I'm multiplying the two, the the property that we end up using is called distribution. So we multiply what's on the outside to both terms on the inside. So if I take 4i times negative 6, well, that's just going to be a negative 24i. And then if I take 4i times a positive I, well, that's just really going to be a positive 4i squared. Now, some things to note with imaginary numbers is once we get to this point, we can't just stop like we would with regular variables. If you remember, the imaginary number I is really equal to the square root of negative 1. Now this is going to be important because if you look in this second term, you'll notice that I is being squared. Well, if I look at I squared, well, I squared is going to be equal to the square root of negative 1 squared. Well, if you square the square root of negative 1, I squared is really equal to negative 1. So this part of this term is really equal to negative 1. So I have a little bit an extra step to kind of do before I'm done with the problem. The negative 24i stays the same. I can't do anything with that, so that just drops down. However, I have 4 times this negative 1. Well, if I take 4 times negative 1, that's really just negative 4. And then I have negative 24i in front of it. Now, if you remember, with complex numbers, we usually write them as a plus or minus b times I. We usually write the real part first, and then we write the imaginary part. So in this problem here, I'd want to rearrange this as negative 4 minus 24i. And once again, the reason why I'm doing that is because it puts the real part of the problem there, and then it puts the imaginary part second. But ultimately, my answer is going to be negative 4 minus 24i. Now, looking at example 2 here, you'll notice that I have two complex numbers. I have 9 minus 2i times negative 4 plus 7i. In this situation, we're going to follow the principles of multiplying two binomials together, and usually the method we use for multiplying two binomials together is known as FOIL. It's really just an organized way of doing a distribution. Okay, so in this case, if I want to use FOIL, the F stands for taking the first term times the first term. So in this case, that's going to be me taking 9 times a negative 4. Well, if I multiply 9 times negative 4, I get negative 36. And then I move over to the O. The O stands for taking the outer terms multiplied together. Well, in my case, that's going to be 9 times 7i, or plus 63i. I then take the inner terms and multiply them together. So in this case, it's going to be negative 2i times negative 4, which is a plus 8i. And then lastly, I do the L, which is the last terms multiplied together. So that's negative 2i times 7i. Well, if I take negative 2i times 7i, I'm going to get negative 14i squared. Now, once again, really the trickiest thing with imaginary numbers is recognizing that there's an extra step to simplifying them. So we can simplify how we normally would when we FOIL. You should notice that these two middle terms can be combined. So I can rewrite this as negative 36 plus 71i minus 14i squared. Really, that extra step occurs with this I squared. And the reason why it occurs with the I squared, once again, is because I is equal to the square root of -1. So if we take I squared, well, I squared would be equal to -1. So we can kind of do a substitution, and instead of having I squared here, we really have -1. So we can rewrite this as -36 plus 71I minus 14 times -1. Then you should notice now, if I take -14 and times it by a -1, I'm going to end up getting a positive 14. So I can rewrite this as -36 plus 71I plus 14. And then my last step here is just to combine the two numerical terms. So if I take -36 plus 14, I'll get -22, and then plus 71I on the end. And always remember, when we write complex numbers, we always once again want that real part first, followed by the imaginary part.